Today we're going to start solving equations. The kind of equations we're going to solve are very simple equations. Most of them can be done with mental math, but we're going to solve equations using steps, and we're going to show our work as we go. And by the time you're doing larger equations, you'll know each step to do. The larger equations you're not going to be able to do mentally, so you have to know the steps to get the answer. We're going to learn on some very basic equations. Today, we're going to basically solve using addition and subtraction. Just basically one step, maybe two. So there are two terms we need to know. The first thing is inverse operations. There are two operations that basically cancel each other out, like addition and subtraction. If I add 2 to something, then I subtract 2 from something. I'm canceling it out. If I multiply something by 2, then divide something by 2, I'm canceling it out. So those are called inverse operations. We use inverse operations to solve equations. The other thing is equivalent equations. And what those really are equations that have the same solution. So if we look at this one, you can do a little mental math here. 2 times what is 4? Well, it's definitely 2. Look at this one. It looks different, but x in this one, what plus 2 is 4? It's 2. These are equivalent equations because they have the same solution. And what we do when we solve equations, we create equivalent equations. So we change it up, but the solution stays the same in solving. Okay, so the addition property of equality, which is what we're going to be using today, it says that adding the same number to each side of the equation produces an equivalent equation. In other words, let's look at this. If I have x equals 5, very simple, that's an equation, has an equal sign, okay? Let's say I add 5 to the x, that gives me x plus 5, and I add 5 to the 5, I get 10. Well, notice the solution for this one is the same as the solution for this one. We didn't change the solution to the equation, we just changed the look of the equation. So when you do something to both sides of the equal sign, as long as you're doing the exact same thing, you're not changing the equation up at all. The solution stays the same, and that's how we're going to solve. Let's look at the first few. Okay, today, as you do it, you're just going to write the problem down as is. I always put a line here just because it helps some people to stay organized. So what you want to do is look to the side with a variable. That's going to tell you what to do. You want the variable by itself. When I get to the bottom of this thing, I want x equals something. That's how we know we're finished, when the variable is by itself. Well, the only thing with the variable is an 8. I want to make the 8 go away. The 8 is a positive 8, so I need an inverse operation, plus 8, and to make that go away, to make that 0, I would need to subtract 8. Subtract 8 from 8. And if I do it on this side of the equal sign, it has to be done on this side. So I show my step here, minus 8 on both sides. Then I bring down what I didn't change, which is the x. And then I do the subtraction over here, 19 minus 8. Okay, and that gives me 11. So x equals 11. And that's my final answer. Okay, one step, and we solved. X equaled 11 here, and it equals 11 here. Notice these are equivalent equations. We changed the look of them, but the solutions are still the same. Okay, let's look at this one. Look at the variable side to tell you what to do. I'm going to draw a line here, something that resembles a line. What's with it, the y is the 13. So to get rid of a positive 13, to make it go away, to make it 0, you subtract it. Minus 13, minus 13. These have the same sign, so same sign add. You get negative 20 on this side. And you get y over here. Now, a lot of teachers will have you switch the variable and put it on the left-hand side. So y equals negative 20. Y equals negative 20 for our answer. Okay, look at this one. Now, until you kind of get to where you're used to subtraction and negatives and things like that, always I get you to change the subtraction to an addition sign. So we keep it, change it, change it, okay? So now I've got a negative 4 I need to make go away. So the way to make a negative 4 go away is a positive 4 because they equal 0. Opposites equal 0 when you add them. So if I add 4 to this side of the equal sign, I have to add 4 over here to keep the problem the same, to keep the equations equivalent. I bring down the x. Then I have a negative and a positive, so I subtract. It's 11 minus 4, which is 7, but it's negative because the 11 is the bigger number. Okay? Here, we are going to bring the line down. I'm going to change it, change it. Okay, so in this one, I've got a negative 61. I want to make the negative 61 go away. Add 61. Add 61 to both sides of the equal sign. When I do that, bring the x down. You get 787. Those are both positive, so you add them. And again, you might get a teacher that wants you to have the variable on the left-hand side. Just flip it around. Okay, x equals 87. Okay, this one, we're going to bring the line down here. Here we're going to subtract 7 because it's a positive 7. So minus 7, and if I do it on this side of the line, I have to do it on this side of the line, the equal sign. So I get x equals 6, and I'm going to go ahead and flip that around, make it x equals 6 there. Okay, now this one, we're going to have to move over so you can see it. Let's push this way and bring this over this way, and I think you can see it now. We'll do a different color here. Bring the line down this way. Okay, what's with the variable that has to go away? Well, it's a negative 5. Okay, so to make a negative 5 go away, you add 5. And if I add 5 to this side of the equal sign to keep the equations equivalent, I add 5 to this side. Bring down the x, that hasn't changed. That equals 0. That just cancels out. It goes away. Okay, here, and then it's a negative and a positive that tells me to subtract. 15 minus 5 is 10. Bigger number is negative, and the x is on the correct side, so x equals negative 10. Let's look at another slide. Let me get another color here. Okay, this one requires an extra step. Okay, notice we have two numbers with the variable instead of one. Okay, so the first thing we're going to do is get rid of the subtraction sign, keep it, change it, change it. There we go. Now, what you want to do is we want to go back to our last lesson, which is adding like terms, simplifying expressions. So what we want to do is simplify this expression right here. So we have a positive 5 and a negative 8. They're both constants. They can be added together. Well, in this case, they're opposite signs, so you subtract. So it's 8 minus 5, which is 3, and it's a negative 3. So I'm going to bring this down and rewrite it. X plus negative 3 equals 7. Would it be the same if I put x minus 3? Yes. Would it be the same if I put negative 3 plus x? Yes. Okay, it really doesn't matter which side the negative 3 is on. If you're adding, it doesn't matter. Okay, now this should look like something we've done before, and again, I forgot to do this. I usually put the line there. I've got a negative 3 here. I want to make a negative 3 go away, so inverse operation, adding, plus 3, plus 3. I've got x equals 10. Okay, and you're done. Here we want to keep it, change it, we'll make everything addition. So I want to add like terms first. I want to simplify this a little bit better than what it is. So what I'm going to do here is I'm going to rewrite it, and I'm going to put those together. I've got a positive and a negative. That means to subtract. So it's 13 minus 2, which is 11. That's plus 11. That equals 5. Okay, now we're going to use an inverse operation to get rid of the 11. It's positive, so I'm going to do negative 11. That makes it 0. Negative 11 over here. X equals, okay, different signs, subtract. 11 minus 5 is 6, and it's a negative 6 because the 11 is larger. Okay, let's look at this last one. Basically, this is the same as the last two problems we're doing. It's just with a shape. So if the perimeter equals 34, that's the total. I'm going to make an equation because we're going to solve it. Then to get the perimeter, you add all the sides. So it's x plus 11 plus 14. We're trying to find the missing side length. Okay, so what we want to do is this. We want to simplify this by adding like terms. And the like terms are these constants here, 11 and 14. When I add those together, I get 25. Okay, that equals 34. Now I'm going to subtract 25 from both sides. And I bring down the x because it hadn't changed. That goes away. It just becomes 0. I certainly don't need to write that. And 34 minus 25 is 9. So our answer in this case, because it's a side length, we have to include the units with it. It's 9 inches. And that's our missing side length. Okay, let's do one more thing. This isn't really an equation. It's an expression, but it's just practice writing expressions. So we're going to read, a plumber charges $195 for parts. And again, if you're writing an expression, you want to kind of pick out what's important, and that sounds important. $45 per hour. That sounds important. Write an expression. Now, expression doesn't have an equal sign, so we're not going to have a total or anything like that, just an equal sign, no equal sign. Write an expression for the total amount the plumber charges for a job after working H hours. Okay, they're giving us the variable we're going to use. So we've got three things here. We've got $195 for parts, $45 per hour, and H, no equal sign. So here's what we need to think about. 45, the word per right here is telling us in the equation that it's multiplied. When we solve that equation, eventually we're going to divide, but this means it's multiplied when you're writing the equation because it's added over and over again. The more hours he works, the more money he gets. So it's being added over and over again. So that's multiplication. Repeated addition is multiplication. So it's 45 times hours. It tells you exactly what it's multiplied by. Hours is H. So it's 45H. Okay, $195 for parts, that is a one-time charge. That is not added over and over again, so it's not multiplied by anything. So it's just added in, plus 195. And here we have an expression. There's no equal sign in an expression. 45H plus 195. That should sum up today's lesson.